Hello friends, so today we are solving this problem, modify graph as weights. So basically this is a hard tag problem, and basically the example given in the this Leetcode explanation is very straightforward cases. We will take some complex cases as well so that things would be very clear. Okay, so first of all let's take one of them, which is a favorite one. So what is happening over here is like one undirected weighted graph is given to us. Okay, starting from 0 to n minus 1. Okay, now there is one thing that some edges are having the weight equal to minus 1, basically, which is negative, right? And others are positive. So our task is to modify all edges with weight minus 1. So one target is basically given to us. Okay, so we are given source. You can see here what all things we are given. We are given the edge like this. So this edge I is basically, this is the starting from A ending at B, and weight is W. Now we are given this kind of thing, and top of that we are also given a source and destination and the target. Okay, so consider, let's say we are given a graph like this, because any edge would be definitely express some graph only. Okay, so starting from source, for example 0 here. So starting from 0 we are supposed to reach destination 1. So 0 is here and our 1 is destination, which is at here. So first of all what we have to do is we are given one target. So between 0 to 1 we have to find the minimum distance. Okay, there could be multiple ways, right? But we have to find the minimum distance. Now what will happen if this minimum distance is not equal to 5, basically the target? In that case what we can do is, whatever negative values are given to us, we can change those negative to some positive. Okay, for example in this way, initially what it was given 0, you can see here 2 to 0 it is minus 1. So this was initially minus 1. Similarly 0 to 3, that is also minus 1. This was also minus 1. Similarly 4 to 3, that is minus 1 obviously, and then 2 to 0, that is also minus 1, and 4 to 1 is also minus 1. Okay, this was like this. Now as you know, we are using to get the sorted distance, what we do, we use the Dijkstra algorithm, right? But we know the Dijkstra algorithm doesn't work for the negative weights, right? So what we will do is, if we first of all, if we want to use at all the Dijkstra algorithm, we have to exclude all those edges which are having the negative values. So in this example what will happen, these things would not be at all, right? And this also would not be at all. So if we now take this graph, this would be something like this. It would looks like 3 to 0, right? 3 to 0, and these are the only, this is the only edge that doesn't have the negative value. So this has the value 3. But see here, our source is 0 and our destination is 1. So now when we have removed in the sense, in that case our Dijkstra algorithm will give the infinite value, because 0 to 1 there is no path, right? Because now 1 is excluded here. Similarly this guy as well, 2, right? Because all they were in the negative ways. Okay, so all these 1, 2, 4, these are excluded from the original graph. Now we have only this one, right? This is excluded. So in this case what it will give, if I use the Dijkstra algorithm, it would give me the infinite value, right? Integer dot max value. Okay, so this max value would not work because this is not equal to target. So what we have to do is, basically we have to start adding the edges which we removed with the value, instead of negative we can put the increasing value, let's say 1. We can start with the 1. So what we will do is, here we will start adding them. So see here, I'm first adding this, adding back 3 to 4, right? So I'm adding back 3 to 4 and the value as 1, because it is given that negative values we can start with some positive values. So I have now given the weight. So what would be the now value of sorted distance between 0 to 1? What would be the sorted distance? Again, there is 1 is still not there, right? So that would not be possible. it will again give infinite value, which is max value, you can say, right? So max value, so still we are not getting the desired target. Now what we will do, we will again add this another edge which we just removed, right? So we will, let's say we are adding this guy as well, this is 4 to 1 which we removed. Now we are adding with the weight equal to 1. Now if we check what would be the minimum value of the distance between 0 to 1, now you can say this is 0 to 3, 3 to 4 and 4 to 1. So 3 plus 1 plus 1, it would be 5, right? And what is our target? Our target is 5. So now these modified values, right, instead of -1 we have to make it +1 and +1, right? Then this will give us the answer wherever we have make change, right? We change the weight of these things, right? So this is the way what we are doing, but this is the one of the simplest case. We can take one more good example which will cover a lot of cases. Okay, so guys, we can take the example of this case. So basically you can see this graph, right, where we have 0 to 1, 1 to 2 and 1 to 3 are -1, and 0 to 3 and 0 to 2 they are positive. I have made it in the green color. So see here, our SRC, our source is source is 2, okay, and we have to reach 3, okay. So 3 is our destination, right, and our target is 8, correct. So first of all what we do is we will find the using Dijkstra algorithm, we will find what would be the minimum path distance between source and target, basically 2 and 3, okay. So here you can see from 2 to 3, where is the, what are the path? So one path is, right, we can go to 2 to 0 first, right, 2 to 0 and then 0 to 3, right? This is one path. So what is the sum? 5 plus 2, it is becoming 7, right? But our target is 8. So now what is the answer of this question? Answer of this question is null. Okay, now why null? Because some of you might have a question that what if instead of -1 and -1 here, what if I make 2 to 1 as 4, right? What if I make 2 to 1 as 4, because -1 can be replaced with the positive values, right? With this assumption, you might have a question that what if I make 2 to 1 as 4 and 1 to 3 also 4, right? So in this case what will happen? 2, 1, 3 could give us a target, correct? So in this case the answer should not be null, right? This is looks like that. So see here, we will go to 2 to 1 first and then 1 to 3, right? And instead of -1 and -1 we can put these value 4 and 4, right? And that case what will happen? 4 plus 4, 2, 1, 3, we will get 4 plus 4 which is 8, which is also our target, right? But why our solution is giving null? Actually what is happening over here is, whenever we are getting the minimum distance between source and target, okay, we are basically calling the Dijkstra algorithm with excluding these -1 edges, right? In that case it is giving us 7, which is basically less than target. So whenever the thing is less than target, whenever the minimum distance itself is less than target, we should not look for a solution which is making a greater target, right? So in this case what happened? We already get 7 which is less than 8. So if we look for the 4 plus 4, if we make this combination, this will give us 8. But we are solving a problem, we are here to make a minimum distance. So if something is already minimum, we are not supposed, because it would be breaking our assumptions to get the minimum distance. We want to minimize, right? Now if we are already getting something which is less than this target, that means we don't have to make any change, we should return the null. We are not doing any change anywhere, okay. That is the reason. So whenever at first time excluding these -1 edges, when we are calling the Dijkstra algorithm, if we are getting the value between the source and target lesser than this given target, right, in that case we should immediately return a null array, because we are already at the best position. But in case if something which is greater than target, right, greater than target, in that case we have to basically greater than or equal to target, in that case only we have to look for the further steps. So be clear with this thing. So what would be our approach to solve this problem? So number one is we have to basically construct our adjacency list. Okay, we will construct one adjacency list, and first of all initially what we are doing, this adjacency list would be excluded all the edges which have the negative weights. Okay, so we will make a adjacency without negative edges, right? So we would be excluding lot of edges wherever it is -1. Okay, without -1. So after getting this edge, what we will do, we will basically run the Dijkstra algorithm. Okay, and those who guys are not aware of Dijkstra, I have put a link in the description box, you can watch it. Okay, then we are calling the Dijkstra algorithm over here. Now this Dijkstra will give us some the minimum distance between our SRC and target, right? Source and destination. Now this source and target, source and destination distance, we will check it. So number 3 is if this destination, if this distance between SRC and destination, if this distance itself is less than the target, what we will do, we will return an empty array. Okay, we will return an empty array, new int 00, that's it, right? So otherwise what happens in otherwise case, it would be distance would be either greater than or equal to target. In that case what we gonna do is we will one by one add all those edges which we removed initially, all the negative edges. Okay, then we will keep on adding, and every time we will call the Dijkstra algorithm. So whenever we are getting equal to 8 means equal to target, in that case we gonna get the solution, we want to return the accordingly whatever weight we made the change. Otherwise we will keep on going that. Okay, so this would be our approach. So we can do a dry run over here for this. So what will happen, first of all, our Dijkstra would be like this. We wouldn't include these guys, right? This will not be there, this is because it is also -1, this also would not be there, this is will not be there, right? We would be without these edges. Now this is proper where we can call the Dijkstra. Now in this step Dijkstra would be giving us like it is giving 7, so that is why we are returning null. Now let's say we are making a change, let's say it is giving us suppose this is this target is 10. Let's say we are changing a bit because we cannot run away only the one type of cases. So let's say this time target is 10. Okay, so what will happen, no, we can make a smaller target. So let's say I want to make it somewhere, let's say we are making this 5 and 8. Okay, so our target is 10. So see here in this case what will happen, what will Dijkstra algorithm will give the distance, it will give us 13, right? Between 2 to 3. Okay, 2 to 3 there is only one path, 2 to 0, 0 to 3. So 8 plus 5, it would be 13, right? So now in this case what is happening, 13 is basically greater than 10. So we have to include these edges, right? So what we're gonna do is, because this is less than or equal, this is greater than this target, so we will let's say one by one we will add our edges which we already removed. Now this time when we add it, we are adding the weight 1 as per the question. So we can give any value which is positive for our convenience. So now in this case we call Dijkstra, what would be the, still it would give again, the answer would be still 13, right? Because still there is only one path, right? So even after adding this, it is giving me 13 only. Okay, now let me add this guy as well. Okay, so this also having weight 1. So what will happen in this case, we have another one, 2 1 3. So this time what would be the distance, shortest distance, it would be, we can go through this path 2 1 3. So this time it is giving us only 2, right? Within the 2, so we can give this 2. Okay, now what would be the next thing, so we are still 8 less of the target, correct? So what if I 10 minus 2, it would be 8, right? What if I replace this guy with 8, right? If I replace this guy with 8 in the next iteration, because I have the liberty to change these guys. Now what would be the distance, min distance here? This time it would be 8 plus 1. It would be 9, right? Now again I have like one more needed. So if I can make this guy as 2, now what would be 8 plus 2 this time? So distance would be this time 10, and we are looking for the target, correct? This time target and distance are becoming same. So 8 to 3, this is one of the solution. There could be multiple solution. It could be 9 and 1 as well, like that, right? So we have to return one of the combination. So this is what we are operating. Let me show you my code quickly. So see guys, this is my Dijkstra algorithm. So those who are not aware of it, you can watch. I have given the link of it, and see here I am creating my adjacency list. I just created it as a class variable. Okay. So see here, this is my main method. So what I'm doing here is, first of all, I just filling the adjacency list. Okay. So see here, I'm excluding all those edges which are having negative thing, right? And I'm adding these to my adjacency list. So whoever is connected with the 0, this is the next edge, and this is its weight. And now because this is an undirected graph, so we have to edge the both directional edges, right? If it is connected 0 to 1, then 1 is also connected to 0. So for that reason I'm doing this. Now see here, I'm first of all, after excluding all the negative edges, I'm calculating here distance using the Dijkstra algorithm. Now you can see here, after doing that, see, we are checking whether whatever distance we got, the minimum distance between source and destination, if it is lesser than target at very first time, then we are immediately returning an empty array. See here, this is an empty array I'm directly returning. Now this boolean variable I'm taking whether distance was equal to target or not. Okay. Now see here, we are again going through the edges, and this time what we are doing, for all those negative edges we are adding them, right? Based upon is equal. If it was equal, then we are adding max, otherwise we are making the 1, and again adding those both directional way. Now see here, after adding these negative edges with the weight 1, we are again calculating here this Dijkstra algorithm distance. So if distance is less than or equal to target, this time we are inside it, right? We just got here when we were having 1 and 1, it was coming 2, right? So for that combination, we are, even if it is less than or equal to, we are going to close to target. So in this case, is equal would become 0, and see here, as 2 equal to whatever as negative as we have, we are making target minus distance. So it would be giving us directly distance that is required for us. Now finally we will be having all the modified things in this edge array, right? So if is equal, so if it is equal, that means we are returning this edge. If this is not equal, that means there might not be any solution. So we are again returning this empty array. So let me try to run my code. It is working fine. Let me try to submit it. I'm submitting it. Yeah, so it is accepted. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.